So this first session of our full center meeting is a workshop panel session designed to allow you to ask questions, all those questions you've always wanted to ask but haven't been prepared to, about how you do make that decision between focusing on academic career paths and things that support that sort of pathway versus more applied translational types of things. So we've got 4 panel members today, a couple of whom are in the sense of Gordon, Wallace, and Maria Forsyth, who of course are well known to most of you as senior members of the centre. But you might be surprised by some of the translational type of experience that they have. We may think of them as sort of pure blood academics, but you might be surprised. And then we've got 2 others who I won't steal their thunder by starting to introduce them in detail, but Charlie Day is a chemical engineer who's had many years experience at the sort of university industry government interface. And similarly, Paul Barrett, also a chemical engineer by training, who's some of you will know from the Aquahydrix days, has many long years experience in electrochemical science, so to speak, translated to industry. So with that said, so prepare your questions, think of your questions as we hear from our 4 panel members, and then we'll open up the floor in the usual way in one of these webinars to questions and discussions. So welcome to our panel members. Thank you for taking the time to join in here today. And can we kick off? I mean, Gordon, would you like to take the first slot, please?
Sure. Thanks, Doug, and thanks to all of the other panel members for joining in. So Doug just asked us to give a little bit of a brief introduction as to how we've encountered translational research or working with end users in the course of our careers, I guess. And it really all started for me in my very first electrochemical project, which was working with medical practitioners developing an electrochemical method for determination of malonaldehyde in cervical mucus to try and create different pathways for adverse behavior using copper IUDs at the time. Then even through my PhD, I was involved with a range of industries, developing online electrochemical measurement systems with copper refineries, nickel refineries, electrolytic zinc, and continued to do that with the electrochemical manufacturers of instrumentation for quite a number of years. But I'd have to say that my eyes were, in terms of end user engagement, really opened up with my encounter and subsequent collaborations with Graham Clark. If there's one book that you need to read in terms of translational research, particularly in the medtech space, it's Sounds from Silence, the Bible of translational research, which really talks about Graham's journey, not just in the technical hurdles that had to be overcome, but how he had to build that translational research team, which was interdisciplinary from a technical point of view, but also with financiers, manufacturers, regulators, social awareness of how he could implement his technologies as well. And that really led to us today, what we have, I think, in terms of that translational space for medtech, an amazing clinical network, but incorporating all of those other skills as well to look at big challenges in skin regeneration, bone regeneration, cartilage, islet cell transplantation, and similarly on the energy side. And Paul will talk a little bit about this, but I was fortunate to be involved with Aquahydrix in its formative stages and to learn from those experiences. We continue to work on new electrolyzer technologies, including carbon dioxide capture technology with Chung Lee that we're looking for translational pathways for at the moment. And in the material space with graphene advances in particular, our initial graphene work being licensed to Imagine and now looking at edge functionalized graphene. And of course, there's a few other things that didn't turn out as being so concrete along the way. Some of you will remember that we were involved in the Bionic Bra project, a very much end user driven project, but never really got to the shelves. And there's reasons for that. We've been involved in a robotic fish project for environmental monitoring, and the Sweat Watch project for monitoring sweat for physiological monitoring. And all of those have their own challenges in terms of translation. But from every one of those projects, you take away a different lesson, different things that we can learn and accumulate that knowledge along the journey. And it's all been fun. So that's it, Doug. Hopefully I didn't take too long.
No, that's perfect, Gordon. And as I was saying before, I think that sort of background might be almost a little surprising to some of our team here, who, as I say, think of many of us as being a rather pure academics. And in a similar vein, Maria, do you want to just tell us about some of your experiences along the way?
Oh, sure. So I guess a bit like Gordon, I probably first encountered translation, if you like. Actually, my PhD, which was looking at cryopreservation, cryobiology of all things, the translation there was with Alan Trounston and the IVF group, right, looking at the science we were doing actually being utilised in the husbandry area at the time. But actually, where my work has been more in the energy space was when I was working as a PhD student, waiting to get my postdoc. I started working with Doug actually with a company called Telectronics that was in Sydney, who were making pacemakers. And pacemakers, for those of you who don't know, have some massive big aluminium electrolytic capacitors in them, which are like 750 volts each, are really big. And Telectronics wanted to actually make these smaller and lighter, and so they wanted and safer. And so we worked on the then newly developed solid polymer electrolytes, PEO of all things, and looked at trying to actually go all the way from making the electrolyte through to making these capacitors in the dry box. And Doug was heavily involved in that as well, but we called them the SPIEL capacitors, the solid polymer electrolyte aluminium electrolytic capacitors. That work, I think in the end, Telectronics probably sold it off to America somewhere and went offshore. But that was my introduction to translation. And then that also led me to really the career I have now, because from there I went to America and did more work on polymer electrolytes and other electrolyte systems. And while I was there, I learned about conducting polymers, polypyrrole, polyaniline, many of you know. And that brought me back to Australia to work at the Defence Department, DSTG, again in translation of those materials for radar absorption, for microwave absorption material, next generation stealth materials, if you like. So that was sort of another translation, if you like, of the science that we were doing in the conducting polymers at that stage. And then I guess from there, more recently, really back to the electrolyte world and looking at how we can build different bespoke devices, different batteries or capacitors, which actually use, which we work with industry, such as the materials industry. So we translate the science that we do in the lab through other industries into the energy storage world. People like Calyx for molecular as examples, where they're developing materials and we're translating those, I guess, into devices. And I guess the most recent example of translation for me really is to the development of battery hub that was set up at Deakin, which was set up to be able to do that translational piece, take the materials that we were doing in the lab and develop prototypes that could then be shown to industry and grow an industry in Australia around energy storage. And at the moment, actually, we are looking very much at going that next stage with that, larger scale prototypes, looking at potential startups in this area. And so even though I do my fundamental science and look at dynamic simulations and all that NMR, there's still this other aspect of what really drives me, I guess, which is being able to translate all that into this into the energy storage devices and energy storage field. So that's it from me.
Thank you, Maria. It was interesting your point that that some of that early translational work that you did with the capacitors effectively set the scene for a good part of the rest of your career in the sense of kind of what you did with it and where you went with it. And I certainly recall, in terms of translational sense, out of that project, the time that Maria gave herself a shock out of one of those capacitors that wasn't discharged. So 350 volts, probably, Maria, is that right? And managed to translate herself all the way across the lab. That was one of the greatest translational experiences I've ever seen out of that project.
Yeah, I also remember putting those into our garage back in the days when safety wasn't such a big deal, and actually discharging them with chart recorders, looking at following the voltage as a function of time in the garage. Wouldn't do that now. Don't recommend doing that.
That's right. Real garage experience that was. That's another translational experience, I guess, Hewlett-Packard style. Charlie, is Charlie with us? Do you want to? Thank you, Maria. Charlie, do you want to take over?
Yeah, sure. Thanks,
Good.
Doug.
Thanks, Charlie. Please.
Yeah, my interest in translation really came during my PhD, which I did at Oxford University in the turbo machinery lab there. And there were two things about it that kind of really sparked my interest. The first was that in fact, the whole lab that I was working in was heavily sponsored by Rolls-Royce. And so my particular interest was looking at the aerodynamics and thermodynamics of a gas turbine, effectively a 747 jet engine. And this was working very closely with the Rolls designers who were trying to solve some specific heat transfer and aerodynamic problems. And I remember at the time that it was about then that I think it was Qantas changed their route. You used to have to fly from LA to Sydney direct, and then come down to Melbourne because they couldn't make it all the way from LA to Melbourne. But during that time, they actually changed. They had enough extra gain in fuel efficiency, they could fly direct from LA to Melbourne. And that felt to me like a very tangible way in which, some fairly fun, we were looking at very fundamental aspects of aerodynamics and thermodynamics of turbines. But that's how that could actually have an impact in the real world. And so I really enjoyed working with the engineers at Rolls and understanding how they were taking my research and incorporating that into their designs. And then the second thing that happened at the same time was that at Oxford University, you all live in colleges, and the guy across the corridor from me was actually also in the engineering department there, but he was working on supersonic nozzles, effectively design of transonic supersonic nozzles, and particularly the application was to fire particles of vaccine through the skin. So effectively you could inject someone without a needle. And that became ultimately a spin-out company from Oxford University called Powderjet Pharmaceuticals, which ended up being worth hundreds of millions of pounds and made this PhD student and his supervisors and all them around him very, very wealthy along the way. And that was interesting to me because at the time I had no concept of what a spin-out from university research actually looked like. I mean, I'd gone through Melbourne University Engineering School and I'd never seen a spin-out there, even though they were heavily engaged with industry. And so those two experiences really sort of shaped my view of that it was really exciting to work with research, one foot in research and one foot in business. And so at the end of my PhD, I then spent 3 or 4 years working in management consulting, learning the way that businesses think. It was kind of like doing an MBA and getting paid at the same time. And then after that, I came back to the University of Melbourne where I'd done my undergrad and worked in the tech transfer office there, doing a range of things, including venture capital, investing into early stage companies, some research partnerships, and then subsequently worked on creating a stronger entrepreneurial ecosystem. So thinking about what are the kinds of environments around universities that are conducive to translation and commercialization. So that's really, I guess, the journey that I had. It might sound in retrospect that it was all carefully planned, but at the time it certainly wasn't. I just sort of went from one interesting opportunity to another. But I knew from my time as a PhD student, I was really passionate about this one foot in business, one foot in research. That's probably enough to get started, Doug.
Thank you, Charlie. And that was an interesting point about how one can plan things, but what happens is usually quite different. And I think most of us would nod our head at that because that's often how careers actually evolve. Thank you, Charlie.
You always get asked for the 5-year plan, but I've never been good at answering that question in 12 years.
Thank you, Charlie. So Paul Barrett now, please, can you give us your perspectives, please, on your
hey,
career?
good, thanks, and thanks, Gordon, for having me here to chat, and good afternoon, everyone. Yeah, so kind of like Charlie, my career path hasn't really been planned, but has had a really commercial bias kind of from time zero. So my PhD is in chemical engineering from University College Dublin, and our lab was sponsored by Merck Sharp and Dohme, big pharmaceutical company, and I was involved in the control and optimization of industrial crystallization. So how they kind of one of the steps in making kind of active pharmaceutical ingredients. And it turns out the sensor that I was using in my project was with a US startup. And to make a long story short, I went to work for that US startup. So in about 99, 2000, I moved to the US to work for the company. And kind of reflecting back, it was a pretty tumultuous time in history. You had the .com crunch, right, explosion, and then you had September 11th, right? So it was kind of a pretty strange time to be in the US, but career-wise it was great. I got to learn a bunch. That company that I worked for, we sold to a Swiss company in about 2003. So that was really eye-opening to me, and that, geez, this engineering stuff, you can actually kind of make some money out of it, right? These ideas and companies can be highly valuable. So I ended up working for that Swiss-American company in the US till about 2009. I didn't plan this next step, moved to Australia around then. My better half is Australian, and didn't pick my timing on that one great either, right around the peak of the global financial crisis. So there was not much startup activity going on, and I ended up working at UniQuest, the tech transfer office of University of Queensland, involved in a lot of spin-outs into kind of physical sciences. And through another unplanned move, ended up meeting with Jerry and Gordon probably in 2011, 2012. And we spun out Aquahydrix, and we got US venture funding into Aquahydrix, which is a hydrogen electrolyzer company based off ACES technology. And that company is still going strong to this day. It's based now in Boulder, Colorado, but we had a good run of it in Australia till 2 or 3 years ago. And more recently, I'm working at IP Group, which is a venture capital firm specializing in university spinouts. So kind of building off, I guess, my experience. And in Australia, we now have 12 or 13 companies spun out of Australian universities, and about 250 worldwide. So there's probably not much technology areas we haven't seen, and it's a fun space to be in.
Thank you, Paul. So that was a great introduction from our 4 panelists. So do we have any questions? In the usual way, please either type them into the chat box, and I'll read them out, or get you to speak them out. Or if there's a deadly silence at any point, then please just press the space bar and speak it out. So perhaps I can get the conversation going just by asking all of you to comment on the following. In ACES, we've had a number of opportunities for PhD students and young postdocs to kind of get some kind of experience at this interface, including the entrepreneurial program for young entrepreneurs, which is quite intense, and so on. The question is, should we do more, and or should a new center do more? And how far into topics such as legal agreements and so on, and shareholdings and structures and financing and some of those sort of non-technical aspects of translation, do you think that a student should go? I think there's got to be a line here somewhere. My question is kind of, where is that line, do you think?
Paul was writing something.
Yeah, anybody want to tackle?
I'm just trying to be polite. You be the conductor and let us know when to talk.
No, please just jump in.
So maybe just a couple of thoughts there, Doug. It's probably a pretty broad question, but if I was a PhD student, or reflecting back on my PhD studentship again, was clueless on commercial topics, right? Because it just wasn't a thing back then. I think there's really unique opportunity now for PhD students to be a bit more commercially focused, and there's also a lot more capital and grants to support those commercial ideas. So I think the timing for students these days, it's like the golden era of commercialization. Yeah. And it's really becoming a great trend in Australia that's probably following on from Europe and in the US. I think specifically to your question, I think awareness of legal stuff and shareholdings is important, but to me, that's not the mission critical piece. I think the piece to be like right across is maybe on the more commercial side of the commercials, which to me is like the market, right? So who are your customers? What's your differentiation? I would expect a PhD student to be very fluent in the intellectual property surrounding their piece, because if you're really going to do a spin-off of an idea, particularly in the physical or life sciences, the intellectual property is key. It's not like a software for an app, which might be some spin-offs, but in these science-rich companies, you got to be across the IP. So that would be maybe just some of my thoughts.
That's very, very useful, Paul. I think the IP aspect of this, absolutely, of course. And we try to some extent in ACES to cover those topics, but maybe not giving students experience in handling it, as opposed to just a workshop. You know, there's a big gulf between those two.
If I could just follow up on that,
yeah.
Doug, I think, as Paul was saying, that awareness of end users at the market is important, and I think through engagement in the right sort of environment. So, and I think a future centre, for example, of ACES would take this even further, and that is that we're working with and alongside end users right from the start, right from the start of projects, and I think that's what's changed in the whole research environment in the last 5 to 10 years, is that there is that engagement with end users, helping to direct the research to some degree, but certainly helping to establish the pathway to use of the knowledge that's accrued. And so I think a lot of those other skills are almost acquired by osmosis. If you're working in the right sort of environment where you're engaging with people like that all the time. Of course, there's a need for that formal training, but I think the informal training is equally important. And so getting into the right research environment that emphasizes those things is critical.
Yeah, absolutely. Charlie, Maria?
Yeah, I was just going to add a couple of things. So just to amplify a couple of things Paul said, sometimes when you listen to government announcing yet another inquiry into how to make Australian universities of business work closer together, you get the sense that nothing ever changes. But it's hard to overstate the extent to which I think the environment has changed in Australia in the last 5 to 10 years. And part of the challenge is it takes a long time for that to show up in the statistics that the government looks at. So, it takes a while to build really big and successful companies. But I've been on the ground in this space for nearly 20 years now, and I think it's radically different to where it was even 5 or 10 years ago. So in thinking about a future centre, I think it would be, go without saying that you'd incorporate this, because that's just the nature of R&D in Australia these days. And the second point, again, Paul made this one, I think it's important not to get too overawed about, some of the concepts like legal agreements and all that kind of stuff. I remember in my undergraduate degree, the head of department of chemical engineering taught us engineering economic analysis. And right at the start, he said, look, don't be very intimidated by this, because you're using a lot of terms like return on investment, all that kind of stuff. But if you look at the average accountant's calculator, it's only got a plus, minus, divide, and multiply button. It doesn't have anything else. And as an engineer, you can think a lot more sophisticated than that. And it's kind of a simplistic way, but a lot of the things in legal contracts or whatever sound complicated because they use language that you haven't seen before, but actually conceptually they're not actually that complex. So I do agree with Paul that IP is critical, and that is an area where you really do need to get a strong grounding. But it's really being able to think like a business person does, which is to think about end users and how they will actually apply the technology in practice.
Just on the just on the IP side, one of the problems I guess that we have in the university sector and as researchers is there's this dilemma between publishing, if you want to be an academic, but some of the students want to see themselves as being academics or research fellows, and the IP, and the universities make it very difficult sometimes to protect the IP and understanding when you have IP to protect. That's you learn that. I think we've learned it. Our senior people have learned that to an extent. But how I would be interested to know how Paul and Charles think about how you actually get the student to the students immersed in their project. They're about to submit this paper to Nature or wherever it's going to be, and then you think, oh, I wonder if there's any IP in this we should be protecting. I mean, we think that, but I'm not sure necessarily that students going to think that. But how do we do that? But also, how do we facilitate an easier way of protecting the IP? Because at the moment, it's not easy to do. You can wait 2 years to publish your paper, and by that time, the students' career's, gone.
Yeah, so I probably can't comment on the inner workings of the university side.
Not in public.
That's what I was writing down for that. Just a couple of thoughts, right? If you're doing that nature or science paper, like a ton of work has gone into that, right? And it's usually getting into a high impact journal because it's probably pretty special work or differentiated, right? So it's something unique and new. So that could be the kernel of like a commercial idea. So rather than leave it to the end, right before the publication, like you're sitting in the tech transfer office, that's probably frustrating. Hey, Maria's giving me a manuscript, they're publishing next week, like, what am I going to do, right? So it's maybe just front running that process a bit. And as you're writing up that manuscript, teasing out, does this have commercial potential? Who's working in the area? Haven't read a few patents in the area. What problem does it solve? Teasing out some of those commercial questions. And I think if that end user or marketing approach is thought, as a course, some of the people, I think that stuff will just come naturally because the questions aren't that hard.
Let me just chip in there as well for those of you who couldn't attend the last few weeks. Jerry ran a 2-session thing which included IP and how to do those preliminary searches and things yourself with external assistance from people that he's worked with before. So I'd encourage you to go back and have a look at those sessions. There's some really good practical stuff in there.
Yeah, I've worked with Jerry for like 10 years. He is an outstanding IP practitioner. So if he's teaching it, I would be taking his advice because he has maybe 50 or 60 patent families to his name that he's been really outstanding in crafting.
One thing I would take away from that is that perhaps, and suggest this to everybody who's listening, that it's important perhaps to have an eye on possible IP outcomes from the get-go of any project, so that the whole time that you're thinking about your project and how the data is developing, you're also thinking about, well, is there an inventive idea here? Do I understand properly what an invention looks like? And at what point do I start to talk that way with my supervisor and my colleagues, so that it's always on the agenda rather than just being the last thing on the agenda.
I think the other thing to say is that the downside, one of the downsides with patents is that they cost money and time and effort to get. But the cost profile of a patent is that the first stage, filing a provisional, is comparatively cheap compared with what comes 12 months later, which is generally filing an international specification. And so, I agree with Paul, start thinking about it early. But if you're in doubt, the cost of filing a provisional application and giving yourself 12 months to try to figure out if you really do want to go forward is often more manageable. So, it is one of those things where you get a bit of time, and there's a very clear sort of sequence in the patenting process. There are natural points where you can bail out if it turns out it's not working. So you can buy yourself the option relatively cheaply of getting that first foot in the door.
Mm-hmm.
Just another idea for Centre or Future Centre, and I get to work with a bunch of universities, so this is me maybe sharing a best practice, although I won't name the uni. A research centre I worked with, they had kind of twice a year commercial reviews of the work, right? So I know all the PhD students probably do their technical reviews. Once a year, they'd have like 10 to 20 PhDs present their work, but through a more commercial lens. And they'd have a industrial advisory board or commercial people, only a handful of people there to kind of give feedback. And like the reality, if you get 50 PhD students and 50 really good ideas, probably only a handful are going to be commercial. And it's probably worth getting an early indication on which ones they are, and then focus some of that commercial and IP effort on those ones that have potential. So that's something to consider.
Yeah, absolutely. Any questions or comments? Here we go from Sue. Sue, do you just want to speak that out yourself?
I could. I think Jenny's been waiting for a while. Why don't you go to Jenny first?
Oh, I didn't see that.
Oh, yeah, oh, that's all right. Can you hear me all right?
Yeah.
Yeah.
Is there something I'm not seeing? Jenny, sorry, I didn't see that. I'm looking at this the wrong way. So Jenny, since you're on, why don't you go?
Oh, that's okay. My internet's a bit flaky. You might have to fill in the gaps. So one of you, I think it was Charles, mentioned having one foot in business and one in research. So my question relates to that. So how do you balance the need for the more fundamental research while you're still developing an idea, and then also the need and the desire to translate that into an actual product? And that question relates both about your time, but also how you direct your team's attention in terms of what's the most important.
Yeah, look, that's probably the hardest part of translation, is understanding how to balance the various risks that you're trying to resolve. I mean, the way I think about translation and commercialization is about taking out the risks that sit between you and ultimately a product working. And the way a commercial person generally will think is taking out the biggest risks first, the ones that if this doesn't work, then the whole thing's not worth doing, and you might as well go home. I find researchers often sequence it differently and take the smallest risks out first and build a greater base of confidence before they tackle the really big questions, if you like. And so it's really about thinking, I think, very clearly about what are the risks that I need to take out of my technology on the pathway to a product. And to help you think about that, it's really important, I think, to understand, well, what is actually the end goal that you're going for? What does your customer actually want? Because the most common mistake you see is people either answering questions or investing in solving problems that actually don't make a difference to the final product. And that's, I mean, it might be scientifically interesting and valuable work, but it's consuming resource that could be taking you closer to an end product. So I think there's a lot of work these days in commercialization and translation to really understand what customers need and do that in a really systematic way. So then you can work back and actually plan then how your research moves forward. And I think that's at the heart of any kind of translation strategy.
Can I just add to that in terms of Jenny's question and that balance? I think it's important for all of us, younger and older, to appreciate that you can't do any of this by yourself. And so that balance is really spread across a whole team of people. And I think it's important to get involved in a team where you do have that critical mass with the blend of technical and non-technical skills to make it work. So, it's not one individual that has a foot in both camps necessarily and be split apart, but it's that team that covers the whole conduit of the pipeline from the idea through to the industries, I think, and positioning ourselves as researchers as part of those teams is really important.
That's a good point, isn't it? Also great experience for learning experience for teamwork too, and being involved in that sort of team.
Yeah, I think that's actually a good point, Doug. The type of team, I mean, most researchers will work in a research team, and the types of people that you're working with are quite similar to you, but in a commercialization team, and Gordon's exactly right, it is inherently a team sport. Commercialization team is going to involve a broader range of skills and a broader set of types of personalities and other things like that. And so, one of the skills I think you need to develop if you're going to get into translational work is the ability to work with people who are not like yourself, who think about things in a different way, and work well in that slightly more heterogeneous team than maybe a research team typically is.
Thank you, Charlie. Yeah, I just realized. Sue, do you want to go with your question, please?
Sure. Thank you. And I guess to some degree, Charles and Gordon have already picked up a bit on this. And this came out of a discussion I had with a strategic innovation fund this morning, and really thinking about how we can support researchers at all stages of their careers, but especially as early career researchers, to be thinking about what the market wants and when they're moving to commercialization, rather than simply focusing on what they'd like to offer. And it is that fine balance that Jenny was picking out of, as a researcher, you want to do new and important research, but when you want to commercialize, you do need to be listening for and responding to what the market wants, rather than just pushing what you've got out at them. So are there things we can do to help people to see those two different sides and to balance them well? And in order to make them more successful in commercialization, otherwise they're just trying to push things that nobody wants.
So the question there is what can we do towards that end? Any thoughts?
Yes, I can maybe start with that one, because I mean, I've been in a way doing that by speaking to a lot of stakeholders over the last few weeks for this new centre, right? And I think what we have to do is engage the ECRs, at least ECRs, maybe PhDs, in discussions with the stakeholders, be they government agencies, be they industry, be that whatever, to sort of see what are the needs. I mean, the discussions I've been having have changed my thinking a little bit about what's important, because the agencies we've talked to are saying this is what we need in the next 5 or 10 year time frame. So I think that's a way of framing some really good fundamental research questions, but that have impact for the people you're trying to, for research for an area that you want to have an impact, right? Whether it be whatever it happens to be, whether it be say in the mining area or manufacturing or whatever it happens to be, you can frame the research questions knowing where your work will have an impact. Now, we do that in grants already, but we do it in a way, I've read many, many grants, and oftentimes the grants are, we're going to solve, the next best battery in the world, and it will have all this capacity and all this, lifetime, whatever else, but without really, I suspect, having gone to ask the industry, what do you need for this application? So bringing that in early into discussions with the team, that means in a centre having those end users engage in the research program. That's what I think is one way of doing it, not the only way, but one way that we'll try and hopefully do it.
Yeah, if I may, Maria, I'll build off some of that stuff. And I think that's a good question, because it's difference between technology, pushing out of technology, and having some customer pull. Technology pushes hard, right? You really have to be pioneering, and sometimes it can work if you've got something really fundamentally unique, but it's a high risk, high risk, high reward and kind of scenario. The customer pull to me is all about early engagement, and engagement is used a lot in university. I probably have a different definition. It's definitely talking to people and talking to. I would like to know kind of the value chain of that product. So if we're talking about an end user, a supplier, an integrator, I'd want to understand that sort of tapestry of people out there. And then I'd really, when I'm talking engagement, it's not really, hey, what are you doing? What do you need? I'm trying to uncover what problems they have. And there is kind of technical sales tools. So I early in my career got trained in kind of technical selling. And there is ways to extract that information in conversations subtly, so that you can understand the problem, implication the problem has, and how important it is to that customer to kind of solve that problem. So I think it's that kind of almost commercial thinking here could be helpful. But in the background as well, in addition to that engagement, you've also got to look at the intellectual property. I'll go full circle on this one. It's known what people have put in the intellectual property, particularly if you're going to be commercial, is almost more important what's in the scientific literature. Because like a firm like 3M, as an example, won't publish many science papers, but they have tons of patents, right? So you've got to kind of read both.
Just to add to that, it might seem obvious, Doug, but I think, and you might remember that Chris Gilby ran a program with some of our ACES students, getting them out talking to CEOs and CTOs around, what's required in industry. And I think that a lot of the feedback we got from that, and as I say, it's obvious, but maybe we just need to keep saying it, is that engagement is as much about listening as it is about talking about your own idea, or maybe even more important to listen. I mean, it seems obvious, but I think that's a real skill. People need to learn to listen.
And I think that was the whole point of that exercise of Chris's, was communication at that level, wasn't it?
Yeah.
Yeah.
I was going to add just.
Sorry, go, Charlie.
Sorry, just going to add briefly. One of the more successful commercialization training programs out of the US. It was run by the National Science Foundation called ICOR. And to give you a sense, they got their people to go through a program which encouraged them to have 10 customer interviews a week over 10 weeks. So that was like 100 customers they wanted to talk to try to get an understanding. So when we're talking about, you know, engaging with customers, it's not one or two people you know in the industry. It's actually really pushing out and trying to broaden your networks in the industry, because that alone is a good thing, but also getting as many different perspectives as you can. Now, 100's a lot, so maybe that's too many, but it's more than 2 or 3, I guess, is the point that I would make in terms of getting input.
Yep. Yeah. Cool. And just reflecting on my time 20 years ago as a PhD student, the toolbox that you've got today to do market engagement is incredible, right? So LinkedIn, right, didn't exist, right? So you can now go on LinkedIn and you can find pretty much anybody that works in any field. And if you have a value add message, you can probably strike up a conversation with them. And even in a pandemic, you don't need to go visit people. You can Zoom, you can call. It's relatively easy to do this compared to 10, 20 years ago.
Absolutely.
Yeah, you used to have to get on there.
Yeah.
I'm picking up on some of those ideas that we talked about the last half an hour, so to speak. Reminds me of a kind of activity that I know we've certainly done in my group. I think Maria has. I'm sure the various people at Wollongong have at various times. And to sort of capture it, it's basically the Skunk Works approach to a mini project. Might only last for 2 or 3 months. It brings together a bunch of people from within the group to work on something. Maybe they earn a little bit of extra money, and there's a report produced at the end with a lot of interaction with the company that's paying for it, or at least prompted it as a Skunk Works project. Do you think that's something that's worth building into a new centre? Any problems with actively trying to seek those kinds of projects?
Just on your definition, Doug, of Skunk Works, so this would be a research group that's building prototypes. Maybe I don't understand.
Well, yeah, I might be using it wrongly as well. I mean, what is the background of that term, Skunk Works? Paul, do you?
Yeah, I think it was one of the US aerospace companies, and maybe you'll have to look up Wikipedia in parallel to get it right. But I think they had a really difficult problem to solve. And the CEO set up a parallel team that would work on kind of the crazy ideas to try solve the problem. And it turns out that one of the crazy ideas kind of worked. So
Right.
that became the Skunk Works. Usually most big corporates frown on that word because it's capital intensive to run like parallel teams. But it was just getting creative problem solving, I think, was the.
So you're saying that they run multiple parallel teams on the same problem?
So, sometimes, yeah.
See, okay, that would be expensive. Yeah. Well, so
But
maybe
I think what you were alluding to, Doug, and I know we spoke about this before, is if there was a possible commercially oriented project that had been identified through engagement with industry, that there might be a feasibility study.
Yeah, you bring a multidisciplinary team together to try scope it out, and yeah.
Correct. That's exactly what the sort of thing I'm talking about. So it's not a multi-year project. It involves lots of people bringing their own expertise, and there's usually a report and maybe a prototype or something tried or data produced at the end of it. But I mean, I was thinking back to Maria's story about the capacitor work. That was effectively a mini effort like that, which launched a direction in Maria's career. Absolutely true. So maybe the question is, should we look for more opportunities like that to get our students involved in, and encourage them to figure a certain fraction of their time is spent that way?
Yeah, and I think it comes back to that end user engagement, with the organisation, with the centre. If that's taken to a much higher level from day one, I think projects like that will arise, because it's two-way, right? They have to know the fundamental knowledge that's being accrued within the centre, the skills that are there, to identify which particular commercial opportunities might be appropriate to that centre or our centre.
Yeah.
And just in thinking about how you might structure that, I mean, it's useful to remember that a large corporate will usually think about an innovation process through what they call a stage gate system, where you kind of do a bit of work and then you stop and you reassess where you are, and then you do a bit more. And even a short, sharp piece of work which can help to resolve some uncertainties and make you better informed at the next stage gate can be incredibly valuable. So you don't have to think about these things being big, long-term projects. They can be quite short, sharp sprints that help answer a few questions and enable a better informed decision at the next stage, which is really what the stage gate process is all about.
Yeah, Charlie, I completely agree. And as an investor, we'll think exactly the same way. So if you were to approach an investor like myself, and your performance of your device is here, but it needs to get to here, but you had a nice roadmap that had nice kind of stage gates along the way that would be taking out some of the risk, that's what you could probably conceive of that roadmap even before you've kicked the project off. You know where you need to go. That's always an important thing when you set out on a journey.
Yeah. I think Jenny's got another question. Please, Jenny.
Yeah, thanks. It's a simple question. I'm wondering which countries do this research translation best. I mean, if somebody wants to learn from the best, and why do they do it better than Australia? I'm assuming Australia is not the best in that question. So any comments from the panel about which countries really do this best? What's the best model that they have?
I think Charlie and I will be largely aligned. Charlie, do you want to go first, or I'm happy to throw in a few?
Why don't you go first, and I'll see if I'll probably agree.
Yeah, we'll probably have different angles. So I think there's a few aspects to it. Australia's catching up, right? So there's clearly strong science around, but the translation is not as strong as other jurisdictions. And I think there's a couple of reasons why. One is just entrepreneurs, right? So we talked about multidisciplinary teams. So if you think of US and maybe UK and Israel, there's usually commercial and technical people working side by side, which ends up in this synergistic approach where we end up tackling the right problem because it's commercially relevant. So that's probably one reason, is having commercial people around. Another reason, which I don't think is as true today as it was true 10 years ago in Australia, is access to capital. So to do commercial stuff, you often need access to capital that's non-ARC funded, as an example. Australia 10 years ago was the nuclear winter of venture capital, so there's just none around. Today is again, going back to the PhD students today, there's lots of it. There's not enough, but there's definitely lots of it. So we've got that access to capital. So I think the missing link is just that commercial piece, and that we're talking about it here, this commercial engagement. And maybe one other country, Israel, seems to do it well. They're the nation of startups. They don't often translate many startups to fully fledged big companies, but there's certainly lots of startups there. And I think that's that commercial academic edge. But I think, Charlie, you spent a lot of time in these areas too.
Yeah. So look, I think, well, the first point I make is I'm not sure that countries are the right dimension on which to sort of segment that. What I see is that I see within Australia, there are some universities and even some research groups that do this really, really well, and others that don't do it so well. And similarly, I mean, the US is usually held up as the hallmark, but and places like, I don't know, MIT, Stanford, places like that are truly unique. But you'll also find a lot of universities in the US that are grappling with the same kind of challenges that some universities in Australia are grappling with. So, I always like to say we shouldn't think about this as being something where Australia is inherently not as good as the US. I think we see a lot of variation between institutions, and what we should try to do is to pick up best practice from the various institutions. There is an overlay there, and I spent the last few years working in government policy in this space, and there is an overlay of government policy where government can help or hinder, but that's not in our power to influence greatly, I guess, at a research centre level. So I would focus more on getting the settings at the research group and the institution level right. But there's no, I don't see any reason why an Australian institution can't be as good as a leading institution in other countries if they adopt some of those good practices.
Yeah, I think, and the other thing that's changing, of course, is that all of our universities are at least trying to improve in this space. And the great realization, which is comforting, is that universities have realized they can't do everything themselves in this space, and that there might be expertise outside the university that could be useful. And I think there obviously is, and we've got to tap into that. And adding to Paul's point around the venture capital funding, there's also a lot of translational research funding now available, right? Particularly if you look in the medtech space,
For sure.
the Medical Research Future Fund, for example, and they're all focused on getting products out the other end. So that's the thing that's really changed in the last 5 years too.
And just actually pick up on your point, Gordon, the other thing that I think we finally might have put to bed in this country, this idea that there's a trade-off between doing, if you like, excellent research and good translation. If you look at the statistics in other countries, whether it's Israel or the UK or the US, the universities that are top on their sort of basic research reputation, if you want to call it that, are also the most active in commercialization, whether it's spin out or industry engagement, things like that. It's not a case of either or, it's a case of both and. But as Gordon says, you need to sort of mobilize partners to help you make that happen.
Very good. I think we're almost headed towards the end of our allotted time here. So last chance, panel members, any final comments or anything that you thought might come up but hasn't that you'd like to comment on, please?
I guess I just want to, whilst we're talking about entrepreneurship and translation and whatnot, I think we also want to be clear that it's not for everybody, right? Some of the people on here might be thinking, oh my God, the only way to do my research is by translating. And that's what someone said before, it's about being in teams. And I think that the translation really happens as a result of a team effort rather than individual projects. And maybe in any new centre or anything we do, we might want to think about, I think Doug, you said this before, about having a team that works on a problem as opposed to every student thinking, that they have to be able to translate their project. I think that's important that we don't scare people off doing research because we think the only thing that can be done that is of any value is if it's translatable. It's not. Fundamental research is equally important, but it feeds into teams. I've got people doing modelling that are feeding into very industry-related projects and batteries, but they don't do the translating. It's the team that's doing it. So,
and to be proactive in becoming, an integral part of those teams, I think, is important, Marie.
Definitely. Any other final thoughts? If not, okay. So this has been fascinating. I think it's been recorded, so I think there'll be a chance for others to have a look at this at another time, which is great. So let me simply say thank you, Paul Barrett, Charlie Day, Maria Forsyth, Gordon Wallace for joining us on this discussion today, and we'll leave everybody there.